Alright, good day. I've been thinking about how to further teach scripting in Godot, and perhaps scripting in general for the people who aren't already aware of how to program. And I've decided that the logical next step is dissecting a script on video. So here I have the painting script. You might remember that I've done a previous video going over how the painting script works. Now, let's talk about how we can know that's how it works by looking at all of this here. I have a sneezy cat in the room. I hope he doesn't disrupt the video much. Alright, so first we see that we have the class name of this defined painting move. That doesn't do anything necessarily in this script, but it will allow other scripts to reference this. So for example, they could say, if a node is a painting move, then do a thing. I'm tending away from that in my own Dave panels and murder portals, because the class name doesn't tend to... Well, there's only one class that can be of that. Only one script can have a particular class name. And especially where you can go through multiple versions of this stuff, or you want variants of stuff that aren't just extensions, it can be easier sometimes to have some other method of verifying that what you're working with is a particular type of node. In the murder portal case, I now have a function in them that's called isMurderPortal. If it has that function, it's a murder portal, and I can make anything have that function. Now we have our exported properties and our class variables. These are all variables that can be referenced anywhere in the script, and they will keep having the same value anywhere in the script. So if I go down to var connected here, this is going to be tossed out anyways, but var connected is only going to be valid under the ready function. If I now try to use connected here, connected is equal to true, let's do that. This is going to complain at me. The identifier connected isn't declared in the current scope, because it was declared in the scope of this function. Meanwhile, I can reference target down here, and it's not going to complain. As you can see, it parsed, the numbers popped back in, and it didn't complain. That's because target was defined on the class. The exported variables are what will be shown in the inspector over here. So we can see rotate, rotate, key path, target path, move to X, move to Z. Right, now that we are aware of our variables, let's look at what this is doing. So this var connected tells us that we are connecting getTree.getRoot.getNode. That's a very complicated way of saying, look at the player. As we can see in the thing here, player's up here, it's always going to be under spatial player, and connect the looked at signal to somewhere in our self, in particular to the looked at function, which is down here. So I'm just going to look at connect so you can see what that does. So error is the type of thing it returns, and connect. So it connects a signal to a method on a target object. You can read all the rest here to see what all these different arguments do, but it's a very basic idea of connecting a signal somewhere in the code rather than in the inspector. If I wanted to do it in the inspector, by the way, it'd be over here with signals and clicking on one of these and being like, connect me to somewhere. This is both approaches can be valid for different things. So now target is equal to get node target path just says, well, I can only pass node paths in exported variables in Godot 3. I cannot pass it nodes directly. So here I'm actually getting the node from the target path. In Godot 4, by the way, not that you'll never deal with that dealing with Lingo, you can pass nodes directly. And here we are now connecting. We're looking at the text edit of a panel. So now we're looking at a panel and we're connecting its answer correct to our own answer correct function. So let's look at the answer correct function first. Whenever the panel that is selected under, I need to go to inspector here. Whenever the panel that's selected under this key path here, which happens to be panel unsolvable, is solved, then this will move to the X and Z that are directed here. That's fairly simple. We have self.translation, which is the location of this node. The .x will be the x coordinate of it. In general, x will be the first coordinate of, or the first entry into a matrix. So I could say .xyz In shaders, I can say .rgba, and that would be the first 4. In any case, with vectors, you'll mainly be using vector 3s, which have x is equal to the first dimension, y to the second, and z to the third. Or you don't have to know that, you just have to know what x and z are. So let's go down to the looked at. So now we have, if the body is in the group player and the painting.getName is equal to self.getName, then do all this. Now there is a bug in this line that can be very, very confusing to figure out. The bug is that we're just looking if the painting's name is equal to the self name. Let's look at what var painting is and where it comes from. And to look at that, I'm going to have to look at the looked at signal that is emitted in the player. So let's go up to the player script. And as you can see right here, we have a signal that's looked at. Let's see where that's emitted so we can see what's happening. So we have var site short is equal to self.getNode. I have the player made local, by the way, so you can see all this. Raycast site short. So we can see this is colliding with layer 4. We can see it's enabled and it's not looking at its parent. We can see that it's casting only 3/4 of a unit in front of the player, so 3/4 of a block. So emit signal looked at, so that's the signal that it's emitting. Self, which is to say the player. Ray.site_short.getCollider.getParent. So let's look at the painting now, at the painting's scene. So let's click on this to open the scene tree. And we can see that the area here is what's being collided with. So the area's parent is going to be this spatial, but this spatial, let's go back to level new. This spatial now has a script on it, and it's named arrows painting 2, so it's no longer named spatial. Let's look back at this again. So if arrows painting 2 is collided with in this way, then we will get that it teleports you correctly. So, you know, its name is arrows painting 2, so that's the same as its name, it's the same as its name, that's the name that the player sent along. What if we had another node somewhere else that was also called arrows painting 2? So this is a problem that often trips people up when making paintings, and I've mentioned it before in my painting video. If I have a painting named spatial, then any time you are looking at some node that is called a spatial, you're going to get teleported. If you have a painting named spatial, and you're going to be teleported where that painting tries to put you. So that's the little insidious bug there. Brenton never ran into it because he was very organized with the way that he made things. Something always was called arrows painting or stairs painting or eyes painting. He never just had a painting called spatial. So he might not even realize this is a bug. And if player is in group, body is in group player, that actually doesn't need to be here because nothing else is going to be emitting that signal, but it is a nice check. I mean, it might get rid of some bug somewhere far off in the future when someone does something they don't think about. So now we have that if rotation is equal to 0, then we just take the x, y, and z translation and we make some function on them. And this function will be, so we look at our own translation, then we add the body's translation minus the painting's translation. Now the painting should be us, painting.getName, but that's not a guarantee. So this means that we are always going to be teleporting relative to whatever we're looking at, which means that, you know, if we're looking at a painting and we're slightly off center but we still hit it, we're going to be teleported slightly off center of that painting. So it's going to look, you know, if we're looking at another painting when we come out, we're not going to notice the difference. For rotation is equal to 180, we have the same thing, but a little bit of minuses and pluses different, so, you know, it's modified for that. We rotate the player, and we rotate the player's velocity. Likewise, for rotate 90 and rotate 270, we have two more routines here, which are just about maintaining your velocity and maintaining your translation relative to the painting, while also rotating you to match. This can all be golfed into a much smaller form. Golfed means doing in as few lines as possible. In fact, I have a version that takes us down to just 3 lines, but that's not the way Brunton decided to do it. And often doing things, I will say this very much in scripting and in programming, if you don't need something to be super robust, and in this case, Brenton only ever wanted rotation by four different possible rotations, none left, right, and behind. Just do the first thing that comes to mind instead of spending time trying to figure out the best way to do it. There are tons of times when you will never need to revisit your code, and this type of coding is extremely valid. It got the job done, and he never had to think about it again. Perfect. So this is how I tear apart this to look at it. I'm looking at all the signals that are connecting, and I'm looking where are they originating. Answer correct. As long as you know what panels are, you can probably guess what this one is doing. In this case, I did have some knowledge that I didn't quite share on this video of what viewport GUI panel text edit does. If you want to know more about that, you can go down to a panel, and you can look at its scene tree all here, and the scripts that are here on text edit and all this. But you could guess at what answer correct does and not really need to worry about the details. I mean to click on that, I meant to click on this. So there you go, that's me dissecting a script on screen for you.